All right, class. So today is the 26th of September. It's the 5th week. If you haven't done so already, please make sure that you put your first and last name at the top of your packet. 9/26/22. This week, these are the items that are due. We have our warm-up, we have our homework, and we have a study guide this week, okay? Our assessment, the end of this cluster, which is another word for unit, is on Friday. So we're going to have our unit test on Friday. The last concept to cover in this unit is going to be laws of exponents. Okay, we didn't have a lot of topics in this particular unit. We just had real number system, which is going to be on that assessment. We had ordering numbers, we had estimating numbers, and now we are cube root, square root, and now we are going to be evaluating exponents. You're going to multiply like bases. Hey, baby. Multiply exponents with like bases, divide exponents that have like bases, evaluate exponents raised to another exponent, and then a combination of all of those. We got zero exponent also, forgot to mention that one, and where your exponent is a negative number. All right, all of which is going to be on our unit test on Friday. Monday, we're going to go over the warm-up. If you haven't started the warm-up, I'm going to give you a couple minutes to start that warm-up and complete it. The agenda is on the side board. We have a foldable that we're going to do on laws of exponents. We already folded. We started the foldable. We didn't finish it, so we're going to finish laws of exponents foldable and paste it into our notebook. Okay. And then we're going to do some guided practice, provided that we finish that foldable. Today's guided practice is going to be on multiplying or dividing exponents with like bases. We may only get to multiplying. We may not get it at all. If we don't, we push it to tomorrow's agenda. The homework is already written. It's Monday's homework. Please make sure that you watch the homework help video, which is located on our Canvas page, and it'll be sent to you on remind at 2 p.m. this evening. Questions, comments, or concerns? Let's turn to our warm-up, please. I'm going to give you just a minute to work on the warm-up. I'm going to give you some options here for this. Transformations are how objects move on the coordinate plane. Hey, baby. There are 4 ways in which an object will move on a coordinate plane. The first is translation. Translation is to slide. That's one of the options that this could be. Second move on a coordinate plane that an object could do, an object could rotate or turn. Rotation. Rotation is to turn. From figure 1 to figure 2, did it slide? Did it turn? The third type of transformation that an object could do on a coordinate plane is to flip. Reflection. It could flip over the x-axis, could flip like this. It could flip over the y-axis. It's reflection. And reflection, again, is to flip. And the fourth kind of transformation that an object can do on a coordinate plane is to dilate. It's dilation. Sorry, I spelled that wrong. And dilation is to get bigger or smaller. So you write down which one you think it is. Do you think this object just slid over? Do you think this object turned or rotated? Do you think the object flipped over? Or do you think the object got bigger or smaller from figure 1 to figure 2? Okay. I'm going to pause for the calls and give you a chance to answer that one. Okay, let's look at it. Which one of these do you think? Raise your hand if you think that from figure 1 to figure 2, from figure 1 to figure 2, it slid. That's translation. Raise your hand high. We got one person, 2, 3, okay? Raise your hand if you think the object turned from figure 1 here to figure 2. Raise your hand if you think that object turned to get over there. Raise it high for turn. Okay, nobody. Raise your hand if you think it flipped over from figure 1 to figure 2, that it flipped over this way. Raise your hand for a reflection. One person. 2, 3. Okay. Raise your hand if you think from figure 1 to figure 2 that it dilated. It got bigger or it got smaller. Okay. From figure 1 to figure 2, it got bigger or smaller. One person. Anybody else? 2. All right. The correct answer is it slid. From figure A to figure B, it slid. It did a translation. So the answer here is translation. It's just slid over. Some people chose reflection, that it flipped. If it would have flipped, okay, over from here to here, these letters would be backwards because it would flip over. Okay, they're in the same location, A, B, C, D. If it flipped, then C would be where F is. F would be where C is. A would be where B is, and B would be where A is. It would flip. You would visibly be able to see the flip. Dilation, the object is exactly the same size here as it is here. So it didn't get bigger or smaller. The object is the same shape and size. The size didn't change from figure 1 to figure 2. Any questions about how we can identify that this object just slid? All right. Food Lion grocery store advertises a special 2-liter bottle of soft drinks. The first bottle purchase is $1.50 each, and each bottle after is $1. Write an expression that can be used to write the total amount. Find the total for 5 bottles. Okay, so automatically you're going to have to pay $1.50 for the first bottle. Plus, how much do you pay for each additional bottle? How much are you going to pay for the bottles after you pay the first one for $1 for each one? So it's going to be $1. I don't know why I put L for liter, but that's okay. I'm going to use a different letter. It's going to be $1 for each bottle afterwards. So here we're going to write, we're going to represent the number of bottles with the letter N. And it's going to be N minus 1 because the first bottle is $1.50. If I purchase in 5 bottles, I'm really only paying $1 for 4. So I have to say 5 minus 1, which is going to give me 4. The first bottle is $1.50. If I purchase 7 bottles, I'm going to say 7 minus 1. I'm going to say 7 minus 1 because the first bottle is $1.50. So really, I'm only paying for 6 bottles and not 7. If I purchase $8, I'm going to put 8 right here. The first bottle is $1.50. So I'm only paying for 7 bottles. That is going to be $1 each. So it's going to be N minus 1 here. Okay. So now how do I solve? How do I find my answer here? When I substitute 5 in, got $1.50 plus $1. It's 5 bottles. So we say 5 minus 1. What's 5 minus 1? 4. Okay, type this in your calculator to see what you get. What is $1.50 plus 1 times 4? What does that give me? Anybody? $5 and how much? 50 cents. Okay. All right. I'm going to pause for the calls, give you a chance to write. Okay. So now Monday's homework is already labeled. Remember, you are responsible for all problems. These are the problems that I'm doing in the video. If you don't watch the video, you still have to do all problems. Any questions, comments, or concerns? Where am I going to put this packet in my folder? Say again, babe. Work to do. Take out your foldable that we started. We put our foldable in the work to do section of. We gotta wait for her. Okay. Take that out. Is anyone missing this foldable? Please raise your hand so I can give you one. For those of you that are just now getting the paper, what you do is turn it on this side, show you how to fold it. And you're going to take the top part and fold it down to this dark line in the center. And then you're going to take the bottom part and fold it to the line that's in the center. You're going to take your scissors and you're going to cut on the dotted line. Get my scissors. Okay, open this little flap and you're just going to cut on the dotted line here so you can fold it up. The dotted line here. Turn it over so it'll be easier to cut the dotted lines on the bottom. Okay, and then there you have your foldable. Okay. And once we finish writing everything in, we're going to paste this in our notebook. I'm going to turn it back right side up. Okay, anybody need more time to cut or fold? Aaliyah, are you okay, babe? Are you okay? Okay, just making sure. You okay? You sure you're okay? Shh, shut up. Let her speak for herself. All right, here we go. All right, so the rule is here we have like basis. That means we have exponents. These numbers are alike. So what we do when the numbers are alike is we add the exponent. So the rule here is to add exponent. Write that down and I'm going to show you why this works. The base is the same. Whatever number M is, you're going to add it to whatever number N is, and that's going to be your answer. And I'm going to show you why that works. Please write that down. Let me pause for the calls. All right, let's watch this part. I'm going to show you how this works. Let's use some real exponents. You don't write. All you're doing is just paying attention, okay? Ashley, y'all ready? Julian, you ready? Okay, I want you to understand. Isaac, are you paying attention? Look this way, babe. All right, if I have 2 to the 3rd power times 2 to the 5th power, this is saying, Abby, to multiply 2 times itself 3 times and then 2 times itself 5 times. So I write this as such, 2 times 2 times 2. That's this right here. Bring down the times. Then I write this as 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5. 3 times here, 5 times here. So how much is 2 being multiplied times itself? What's the total amount of times that 2 is being multiplied? Count. Somebody said it? 8. So my answer here is going to be 2 to the 8th power. That's 1, 2, 3, 4, 5, 6, 7, 8. So my answer is 2 to the 8th power. A short way of doing this is to say your base is 2. The bases are alike. 2 is being multiplied 3 times here, plus 2 is being multiplied 5 times there. So that means 2 is being multiplied a total of 8 times. This is the shortcut. Any questions about that? I'm going to do one more. Let's suppose we got 4 to the 2nd power times 4 to the 4th power. Okay? That means 4 is being multiplied 2 times here. 4 is being multiplied 4 times here. So the expanded form or the exponential form of this number is going to be 4 times 4. Bring down this times. And then here, the exponent or the exponential or expanded form for this number, 4 is being multiplied a total of 4 times here. So that's 4 times 4 times 4 times 4. How many times is 4, the base 4, being multiplied in all? How many times is this? 6. Very good, Abby. 1, 2, 3, 4, 5, 6. So my answer is 4 to the 6th power. A short way of doing this is to say the base 4 is being multiplied 2 times here plus 4 times here. So my answer is going to be 2 plus 4, which is 4 to the 6th power. This is the shortcut way of doing this. You cannot do what I'm doing here if these bases are not alike. The bases must be alike in order for you to add the exponents. Okay, so let's look at the examples in our foldable. These are the ones you have to write. I was just writing the other ones. You didn't have to write that one, but you do need to write these examples. Let's look at the first example. X to the 5th power times x to the 7th. Okay, x is being multiplied 5 times here. X is being multiplied 7 times here. So how many times total is x being multiplied? 12. You're going to say 5 plus 7. Please write this. X to the 5 plus 7 power. That means that my answer is x to the what power? 12. Please write that down. Ms. Reyes, how do you show your work on problems like this? This is how you show your work. You show that you are adding those exponents when the bases are the same. This is multiplying exponents with like bases. What's wrong? Tell me. Oh, why didn't you tell me, babe? You want this one? It's already cut. Anybody else need one? Jessica, you okay? I need some more coffee. I need a pick me up. All right, so let's do the next one. G to the 2nd, G to the 4th. How many times is G being multiplied times itself here? How many times here? 2. How many times here? 4. So G is being multiplied 2 times here plus 4 times here. So that means G is being multiplied a total of how many times? 6. So my answer is G to the 6th power. See if you can do number 3 on your own. That's a D. All right. If you don't see an exponent there, it's automatically 1. And this one is 8. What answer did we get for that one? D to the what power? 9. Okay, very good. D is being multiplied 1 time here plus 8 times here. So our answer is D is being multiplied 9 times. Okay. Any questions about multiplying exponents with like bases? Multiplying exponents like bases. Okay, pause for the calls, give you a chance to write. It's Monday for sure. All right, y'all, let's look at this one. This is dividing Okay, this is dividing exponents with like bases. Dividing exponents like bases. What is the rule here, Miss Reyes? I'm getting ready to show you. You don't have to write this part that I'm getting ready to write. This is just the explanation so that you can see if you can figure out what you're going to do in order to get the answers for these. So let's write this and then pause for the cause. I want you to listen to the explanation and then tell me what you think the rule is going to be here. Multiplying exponents with like bases, we add the exponents, okay? So now we're doing dividing. All right. Okay. Let's suppose that we have, I'm going to use 3. I'm going to say 3 to the 6th power divided by 3 to the 3rd power, okay? All right, so on the top, I write 3 to the 6th power. The expanded form or the exponential form of 3 to the 6th power is 3 times 3 times 3 times 3 times 3 times 3. 1, 2, 3, 4, 5, 6 times. Any questions about how I wrote the expanded or the exponential form of 3 to the 6th power? Kate, are you good? Focus, babe, okay? Focus. What about the expanded form for 3 to the 3rd power? Colton, how do I do that? 3 to the 3rd power. How do I write the exponent form or the exponential form or expanded form for 3 to the 3rd power? Okay, very good. So that's 3 times 3 times 3. Okay. Now let's divide. What's 3 divided by 3? What number is that? How many times will 3 go into 3? Once. 3 divided by 3. Come on, let's do it again. Once. How many times will 3 go into 3? Once. What's 1 times 1 times 1? Hello? It's just 1. How many 3's do I have left? 3. So my answer is 3 to the 3rd power. 1 times 3 to the 3rd power is just 3 to the 3rd power. This is my answer. What do you think is a shortcut way to get 3 to the 3rd power in this problem? What do you think I could do where I don't have to do all of this, the expanded form, but I still get 3 to the 3rd power? What's the shortcut way? Remember up here what the shortcut way was? Okay, very good. We're going to subtract. So when we have this 3 to the 6th power divided by 3 to the 3rd, the bases are the same. So we have 3. Our base is the same. It is 3. We're going to say the top exponent minus the bottom exponent. What's 6 minus 3? Hello? 3. So our answer is 3 to the 3rd power. Okay? Let's do another one. See if you can get it. We have 7 to the 4th power divided by 7 to the 3rd power. The expanded form on the top. How do I write the expanded form of 7 to the 4th power? Atiana? Very good. Aaliyah, how do you write the expanded form for 7 to the 3rd power? You got to sit up, honey. You got to focus and pay attention, okay? All right. 7 to the 3rd power, you're going to write it as 7 times 7 times 7, 3 times. Sit up, please. Are you not feeling well? Do you need to go to guidance? It's okay if you do. You sure? Okay. Let me know. 7 times 7 times 7, okay? All right, now let's divide. What's 7 divided by 7? What's 7 divided by 7? 1. 7 divided by 7. Thank you. What's 7 divided by 7? 1. What's 7 divided by 7? 1. 1 times 1 times 1 is 1. Times 7 is just going to be 7. How many 7s are left? So it's either 7 to the first power or your answer is just 7. It's understood to be a 1 there. Okay? What's the shortcut way? It's Monday. What's the shortcut way to solving this problem where I can just get 7 to the first power or just 7? Anybody? Yes, baby. You subtract. The bases are the same. I'm going to rewrite. Your base is 7. Your top exponent is 4. Your bottom exponent is 3. You're going to say 4 top exponent minus bottom exponent. So that's going to be 7 to the first power or just 7. Any questions? All right, so let's go back to the foldable. X's are the bases. The bases are the same. We're going to subtract top exponent minus bottom exponent. So with dividing exponents with like bases, you're going to subtract the exponents. Okay, write that in. All right. So let's do this one. The bases are the same. We got X. Oh, I already did it. Well, no, we did a different one. What are we going to say here? What minus what? We're subtracting what? 7 minus 3. Top exponent minus bottom exponent. So this is going to be X to what power? 4. Okay. Bases are the same. The base is P. What are we going to subtract here? What minus what?
8 minus 5.
8 minus 5. What's 8 minus 5?
3.
So this is P to what power? The third power. Somebody said, good job. See if you can do number 3 on your own. Let me bring it up a little bit so you can see it. See if you can do number 3 on your own. What did we get as our answer for number 3? V to the 6th power. What did we say? The V, common base is 3. What do we subtract? What minus what?
9 minus 3.
And that gives us V to the 6th power. Great job. Any questions? All right, let's do power exponent raised to another exponent. All right, so you say power of a power. This is an exponent raised to another exponent. Okay, and I'm going to show you how that works. Did you write it down, baby? All right, ready? Exponent raised to another exponent. Look at how this goes, y'all. So you have, let me use an easy one. What number? I used 3 already as a base. I use 7. Let's use 5. So let's suppose we have 5. Let's use a small exponent. Let's use 5 to the 3rd power, and we're going to raise it to the 2nd. Watch Miss Reyes write the expanded form. I'm going to write 5 to the 3rd power. I'm going to multiply it times itself how many times? 5 to the 3rd power. What do I multiply all of this times itself how many? 2. Who said 2?
Me.
Good, Abby. We're going to multiply 5 to the 3rd twice. How do we know to multiply 5 to the 3rd power 2 times? How do we know to do that? I'm trying to squeeze more coffee out of this cup. There ain't nothing there. It's so sad. I need some more coffee. All right. How do I know to multiply this times itself 2 times? Because of this exponent right here. So this is, how do we write this in expanded form? 5 to the third. Very good. 5 times 5 times 5. Bring down the times. How many times do we multiply this? Same. So how many total times is 5 being multiplied? Nope. 6. 1, 2, 3, 4, 5, 6. So my answer is 5 to the 6th power. What's a shortcut way to do this? No, adding is going to give us not 6. Yes. Multiplying. We're going to multiply. When we have 5 to the third and we raise it to another power, a power of a power, you multiply the exponents. So this is going to be 3 times 2. What's 3 times 2? So our answer is 5 to the 6th. This is the shortcut. Let's try another one. Let's do 8 to the 5th power, and we're going to raise it to the 4th. Okay, how do we do this one? 8 to the 5th power, raise it to the 4th. What are we going to do with the exponents? Jessica, what do we do with the exponents? We're going to add them, subtract them, or multiply them. We multiply. Power raised to a power like we did here, we multiply. What's 5 times 4? Nope. 20. Say again? 20. What did they do to get 9? Why did they say 9? What did they do? They added. This is multiplication. Let's do another one. Okay, look up here. 9 to the 6th power and raise that to the 3. That's fine. Okay, so what do we do to get our answer here?
6 times 3.
We do 6 times 3. What is 6 times 3? 18. So this is 9 to the what? 18 power. One more. Let's do 20 to the, you're just looking up here. You're not writing it. Enrique, sit up. Let's do 20 to the 5th power. I already did 5th. That's okay. And we're going to raise it to the 7th power. What do we do to get our answer here? 5 times 7. What is 5 times 7? So this is 20 to the 35th power. All right, so let's do these examples here. Let's do this one. What are we going to do when an exponent is raised to an exponent? What operation are we going to use? Addition, subtraction, multiplication, multiplying. We're going to multiply the exponents. Power raised to a power, multiply the exponents. So that means you're going to multiply m times n. Whatever these numbers are, multiply them together. So let's do number 1. What are we going to multiply here? What times what? What's 2 times 3? 6. Number 2, what are we going to multiply here together? 7 times 4. What's 7 times 4? 28. This is f to the 28th power. Do number 3 on your own. All right, what do you get as a final answer? No. C to the 10th power. Because you're going to say 5 times 2. Don't forget this step. This is going to give you c to the 10th power. Any questions? All right, negative exponent. This is when your exponent is a negative number. Exponent is negative. When your exponent is negative, the rule is you're going to write it as a fraction. You're going to do the reciprocal. The numerator is going to become the denominator, and the denominator is going to become the numerator. So this is how that works. You have your fraction here. Your top number is going to be 1. And you're going to move all of this down to the bottom. And so now your exponent is going to be a positive. This is going to be your answer. And I'm going to show you why that works here in a minute. Please just write that down. We're going to do it a couple times, and I'm going to show you why. All right, so this is how you write it. If you have 3 to the negative 2, thank you, Miss Peoples. You're going to write this as my numerator is 1, and move all of this down to the bottom of the fraction, and the exponent is now a positive number. I'm going to do it again. You have 4 to the negative 5. Your numerator is 1, and you're going to move all of this down to the bottom, and now your exponent is positive. One more time. You have 6 to the negative 7. Your numerator is 1, and you're going to move all of this down to the bottom, and now this is a positive number. Okay? So let's write these. How would I write these? What is the first one going to be? My numerator is going to be what? 1. And what am I going to put?
You're going to bring all that to the bottom.
And what's this going to be? X to the what? Positive 4. All right, let's put our calculators back and pick up our cell phone, please.